Okay, this video we're going to look at how to solve rational inequalities. And rational simply means that the equation looks like a fraction, which, everybody loves fractions. But that also introduces a little twist to the problem. We still need to find our critical values. And our critical values for a rational inequality are not only the values that we can use for x, but also values we cannot use for x. Because remember, when you have a fraction, the denominator can never be 0. So again, I initially need to solve the equation for x, but I also need to solve just the denominator. Okay, so if I think about the denominator first, because that's a little bit easier to think about, okay, I would have to be sure that x plus 6 does not equal 0, because you cannot have 0 in the denominator of a fraction. And so if I solve that for x, I find that x cannot be negative 6. So if I begin to think about my number line and breaking it up into the regions like we did for the polynomials, one of my values is negative 6. And I also have just determined that that value cannot be used in the problem itself because it causes the denominator to be 0. Now I want to go through the process of solving the equation. To solve 2 minus x over x plus 6 greater than or equal to 0, I need to eliminate or get rid of the denominator. So I'm going to multiply both sides of the problem by the denominator, which is x plus 6. So when I do that, I end up with 2 minus x is greater than or equal to. And 0 times anything is still going to be 0. And then I need to solve that equation for x. So I have, if I add x to either side, I find my critical value is x equals 2. So my critical value is positive 2. Okay, and then I have to avoid negative 6 because I cannot use that in the denominator. So again, what happens is I have 3 regions. I have a region less than negative 6, a region between negative 6 and positive 2, and a region greater than positive 2. Again, it's the same concept as we had before. We're going to choose a value in each region. So perhaps I choose something like negative 8, 0, and let's say positive 4. And again, you always want to go back to the original problem to check the regions. So I'm going to begin with negative 8 in the original problem. So I would have 2 minus negative 8 over negative 8 plus 6. We want that to be greater than or equal to 0. Negative 2 minus a minus 8 is 2 plus 8, or 10. Negative 8 plus 6 is negative 2, which ultimately gives me negative 5. Negative 5 is not greater than or equal to 0. So this region doesn't work. I'm going to come back and start over, and this time I'm going to do the 0. So I would have 2 minus 0 over 0 plus 6. So I have 2 over 6, which is 1/3, but 2 over 6, or 2/6, is greater than or equal to 0. So that region works. I'm then going to come back a third time, and I'm going to check the positive 4. So I would have 2 minus 4 over 4 plus 6. We want that to be greater than or equal to 0. So I would have negative 2 over 10. That is not greater than or equal to 0, so we cannot use the third region. So what we have here, and again, thinking about could we use the 2, notice that it is equal, so I can actually include the value of 2 in the interval. Okay, so I can do anything in the interval from negative 6 to positive 2, but I cannot use negative 6. So in interval form, I would have parentheses, negative 6, because we cannot use the negative 6, up to 2, and the 2 is included. Guys, you got to be really careful and pay attention to whether you're doing parentheses or whether you should be doing brackets. And it all comes down to, is the point usable or not? If you don't know, plug it into the problem and double check it. All right, let's move to number 2. Number 2, we have 9 minus 3x divided by x squared is less than or equal to 0. Again, we need to think about our denominator. Okay, so I'm going to think about that first. It really doesn't matter which one I do first, but I'll tend to do that first. So I have x squared, and it cannot be 0. If I solve that for 0 by taking the square root of both sides, I find that x cannot be 0. So if I begin to think about my number line off over here to the side, I know that 0, I cannot use 0 because that would cause my denominator to be 0, and I also know that that value cannot be used in the equation overall. Then I need to solve the original equation for x, and again, to accomplish that, I would have 9 minus 3x over x squared equals 0, and I'm going to multiply both sides by x squared. So I would have 9 minus 3x equals 0. Solving for x, add 3x to either side. I have 9 equals 3x. I'm going to divide both sides by 3. So x is 3. So my other critical value is 3. So I'm going to put that on my number line. And again, notice you still have 3 regions. You have the region where you are below 0, between 0 and 3, and then greater than 3. So we're going to choose a value in each region. So I might choose something like -2, +1, and say +5. So then we need to check each of those in the original problem. So I would have 9 minus 3 times -2 over -2 squared. We want that to be less than or equal to 0. So I'd have 9 plus 6 over 4. That gives me 15 over 4. Positive 15 over 4 is not less than or equal to 0. So we can't use that region. I come back and I do the 1. So I have 9 minus 3 times 1 over 1 squared. That's less than or equal to 0. So I have 9 minus 3 over 1. So that's 6 over 1 less than or equal to 0. Okay, that region doesn't work either. Okay, because that's still a false statement. 6 is not less than or equal to 0. All right, and then finally we're going to check the 5. Okay, so I would have 9 minus 3 times 5 over 5 squared, which is less than or equal to 0. So I have 9 minus 15 over 25. That gives me negative 6 over 25. That's less than or equal. That is a true statement. So we're going to use values that are greater than 3. Okay, values that are greater than 3. Now again, we have to think about, can we use the 3? In the original equation, it is equal. So that means I could have a value of exactly 3. 3 would not cause the denominator to be 0. So we're going to start at 3. We're going to work our way to positive infinity. And your answer in interval form would be from 3 to positive infinity. All right, moving on to the next one. I have 4 minus x all over x plus 5, which is greater than or equal to 5. Okay, so again, I'm going to begin by thinking about my denominator. So x plus 5 cannot be 0. If I solve for x by subtracting 5 from either side, we find that x cannot be negative 5. Okay, so I'm going to put that on my number line. So I have negative 5, but it cannot be negative 5 because that causes my denominator to be 0. Then I'm going to solve the actual equation, 4 minus x over x plus 5 greater than or equal to 2. And I'm going to multiply again by the common denominator of x plus 5 on both sides. So I have 4 minus x is greater than or equal to. I'm going to go ahead and distribute the 2. So I have 2x plus 10. Again, I'm trying to solve for x, so I need to get all of the x's together and all of the numbers together. So I'm going to add x. So I have 4 is greater than or equal to 3x plus 10. I'm then going to subtract 10. Okay, I'll scroll this down a little bit so I can have some space. Okay, minus 10. So I get negative 6. Then I'm going to divide both sides by 3. So I have negative 2. So my other critical value is negative 2. Okay, so I'll put that on the number line here. Okay, so again, notice you have 3 regions. You have the possibility that it's less than negative 5. It's between negative 5 and negative 2. Or it is bigger or greater than negative 2. So again, we're going to choose test values in each one of those regions. So let's say I choose negative 7, maybe negative 3, and 0. And we're going to try those and see which one of those critical regions gives us a value that is greater than or equal to 2. So we do our checking, plug and chug. It's the only way to do it. Okay, so I'm going to start with negative 7. So I have 4 minus negative 7 over negative 7 plus 5. And we want that to be greater than or equal to 2. So I have 4 minus a minus is 4 plus 7, so that's 11. Negative 7 plus 5 is negative 2. a negative 11 halves. A negative number is not going to be greater than or equal to 2, so that's a false statement, so we don't use that region. Going back and starting over, checking the second one, I'm going to check negative 3. So I have 4 minus a negative 3 over negative 3 plus 5. We want that to be greater than or equal to 2. So 4 plus a negative 3 would be 4 plus 3 is 7. Negative 3 plus 5 is 2. Okay, 3 halves, if you don't know, or 7 halves is 3.5, which is greater than or equal to 2. So that's a true statement. So I could use the middle region. And then finally, I'm going to go back one last time and check the 0. So I have 4 minus 0 over 0 plus 5 greater than or equal to 2, which gives me, let's see, I got to scroll down a little bit, 4 over 5. 4/5 is not greater than or equal to 2, so that's a false statement. So we cannot use the values in the third region. We need to decide, do we include the negative 2 or not? The original problem contains equal, which tells me we should include the negative 2, and we can do any value in between. So in integral form, we have, whoops, excuse me, let me erase that. The wrong symbol there. All right. It's going to be starting at negative 5, but we use a parenthesis because that point cannot be used. It goes up to 2, and we do include that particular point. So we go from negative 5 to 2, not including the negative 5, but including the 2. Okay, one last one. We have 2x divided by x minus 2 is less than or equal to 2. Okay, so again, I'm going to start with my denominator. I know that my denominator within a fraction can never, ever be 0. So x minus 2 cannot be 0. I'm going to add 2 to either side. So x equals or cannot be negative 2. So again, thinking about my number line, I know that I cannot use 2. Okay, because that would cause the denominator to be 0. So then I'm going to solve the equation 2x over x minus 2 less than or equal to 2 for x by multiplying both sides of the equation by x minus 2. Okay, so when I do that, I end up with 2x is less than or equal to 2x minus 4. Okay, so if I solve this for x, and this was a little bit tricky. Okay, so you got negative 2x, subtract 2x from either side, and you actually get 0 is less than or equal to negative 4, which is a false statement. It will always be false, which means there's no way you can make this particular equation less than 2 at any given point. So we really only have one critical value here, which is a little bit different from all the problems that we've been looking at. So we only have 2 critical regions this time, one that is less than 2 and one that is greater than 2. So I'm going to choose 0 and then let's say 5. So I only have 2 values to check this time. Okay. So let's see, I would do 2 times 0 over 0 minus 2. We want that to be less than or equal to 2. So I would have 0 over negative 2, which is 0. And that is a true statement. So because 0 is less than or equal to 2. All right. Then we try the 5. So I have 2 times 5 over 5 minus 2. We want that to be less than or equal to 2. So I have 10 over 3, which is less than or equal to 2. 10 thirds is like 3 and 1/3, okay? And that is not less than 2, so that's a false statement. So we want to use any value that is below 2, okay? Or to the left of 2. But the 2, in this case, even though it could be equal to 2, we do not include that endpoint because the value of exactly 2 causes the denominator to be 0. So be careful. This one's got a couple little tricks with it all the way around. So be careful. Ultimately, your interval is going to be working left to right from negative infinity with a parenthesis up to positive 2. But again, we do not include the 2 because it would cause the denominator to be 0.